In this video, we're going to talk about lambda expressions, which another way to refer to a lambda expression is an anonymous function. And we can put these in our code and they become very, very useful tools. Now, they're a little bit odd to get your head around at first. So take your time and build a bunch of them that are very small and very simple. And as you begin to use them more and more, they will begin to make more and more sense, and you will find more and more places that you can use them to help you in your code. In this program, we're going to begin to talk about lambda expressions, which are a form of anonymous methods. So we've talked about methods and how they can be either functions or procedures. Procedures basically just perform some task. Functions return a value. Lambda expressions are relatively new on the computer science spectrum, and they really are useful because they allow us to just create a method that we can use over and over again that doesn't have to be a full section of code. I can just put it where I need it, and they're very, very useful because I don't have to formalize the definition of a method. And we're going to explain this as we go. You'll see these very heavily used in C# if you're programming in .NET Core. And you'll also see them in Python, and they're beginning to make a run into Java from what I'm told. So they're going to be very, very useful in your programming career, and we're going to start taking a look at them. So the first thing I'm going to show you is how to define a very simple lambda expression. So we'll say my lambda, and we'll start out with that. My lambda gets assigned, and we're going to use the keyword lambda, which you'll see is colorized, so that's a reserved word in Python. And we're going to say for x, so if we're given x, it's going to return x times 4. We'll keep it really, really simple. So when I call my lambda, I'm going to call it with a value which will be x, and it will return to me x times 4. So let's try it out. Let's say print my lambda of 5. Control save. And let's go see how that works. Oh, I'm in the wrong directory here. Let's go cd school, cd python, and ls. Let's see if we got it in there. Lambda is there, so let's say python lambda.py. And what I get is 20. And sure enough, 5 times 4 is 20. All right, let's try a different print statement. And what I want to show you here is you can even nest these things. So I'm going to say, give me the my lambda of the my lambda of 6. So we're going to take 6 times 4, which is 24, and then we're going to multiply it by 5. So let's see if that gives us what we think it will. We got 20 and 96, and 96 is correct. Okay, so 96 is the result of taking 6 times 4 and then multiplying that times 4. And of course, 5 times 4 is 20, so that is the same. So that is really the essential how to do a lambda. But let's go ahead and show that these can be even more complicated if we need them to be. So let's just call one, I don't know, my big lambda. Okay, and we're going to say that that is now going to be defined as a lambda. And this time we're going to ask that the user give us 2 inputs, and we're going to return the average of them. So we're going to say x plus y divided by 2 is what we're going to return. All right, so let's print and we'll do something where we can really easily calculate the average. Let's say my big lambda of 16 and 20. So we should see 18 when that comes out. So let's try that. Control save. Let's run it again. So there's our 20, 96, and 18. Notice Python took care of making sure that it was a float, so that if there was a fractional part to that calculation, it would be able to show it to us correctly. So 18 is the average we need, noting the data type change because of the nature of the calculation. It works fine. So I can make these complicated calculations and just call this lambda. Now, one of the really cool things, and I'm actually going to put a comment in the code to remind us of this fact, is that lambdas can be used in functions to build multiple forms thereof. Okay, and this is a little bit tricky, so we're going to take our time and go through it. But the first thing I need to do is create a lambda, and I'm going to do it outside of main. So I'm going to say dev, and this is I'm going to call this a division function. Okay, so this is a regular function, and you're going to put in x. All right, and my return is going to be a lambda. Okay, so I'm going to return a lambda expression for y, which is y divided by x. So basically what I'm doing is I'm going to take y and divide it by this x that you give me. Okay, so how this is going to be called will look like this. I'm going to say, let's say I want to have a function that divides in half. So I'm going to define we'll call it haver. My haver is equal to div function of 2. Okay, so when I pass div function of 2, it's going to take whatever is passed in and divide it by 2. All right, and that will be my haver. And let's do one that does quarters. We'll call this my quarter. I'm not going to call it quarterer. Just my quarter equals div function of 4. So now it's going to go up, and that will be the 4, so it'll divide whatever I give it by 4. Okay, and now let's test this one out. Print cutting 12 in half is, let's go ahead and put the period in there and then say dot format. And we're just going to call my haver, make sure I spelled that right, my haver of 12, because I'm going to cut that in half. And then what I'm going to do to save time is I'm going to copy this and paste it and say cutting 12 in quarters is placeholder dot format my quarter dot of 12. All right, so what should I see here? I should see obviously 6 and then 3. So let's see if we're right. Oops, div function of x. I have a syntax error in here somewhere. Div function of x, div function of x. Oh, I wrote dev, not def. All right. And it was telling me the whole time, so I should have seen that. There we go. All right. Let's try this again. Let's do a clear. And let's try this again. There we go. So it works. So I've basically been able to use this function, which returns a lambda, and by setting it up this way, where I'm dividing by a variable, I can create different functions that already use the guts of this. So if this happened to be a very complicated process, I could spawn it in different versions by passing different values for that internal variable. So basically, the point I want to make is lambdas are extremely useful. You really need to think about them when you first start using them. But once you get used to what lambdas allow you to do, then you've got to be really careful to document what you're doing so that someone coming behind you who sees all this really beautiful terse code can follow it. Because you can really get to where it looks complicated even though it's really not. So particularly down here with Havern and my quarter, I'm calling div function with different values, which basically makes them totally unique functions, but they come from the same reusable root. Okay, so it's really pretty cool what you can do with lambdas. So hopefully now you've seen at least a small introduction to lambdas and why they're powerful, and they're just very, very useful tools to have. And we can fit them a lot of places in our code. Be careful that you document what you're doing and where you are using them in your code so that someone can read your code. You never want your code to be illegible. So when you use Lambda expressions, leave trails of what you're doing so that you don't confuse yourself even if you go back 6 months later and look at your code. Lambdas can allow you to write very terse code, which sometimes it has a disadvantage that it's hard to follow if someone's reading it. Okay? But in the next video, we're going to begin to talk about really the last topic before we get into Object Python, which is basic file input-output. How to open files, how to write to them, how to read what's in them. We're going to talk about all of that on the other side.